So let's make a start on that with the first one, which is to sketch the curve. Now, when you're sketching curves, and this is a cubic, so the first thing that I know is what type of curve it is. So if I was to sketch this, the first thing I want to know is what type of curve. This is a cubic, so I know that it's going to look something like this. I also want to know where it cuts the x-axis and where it cuts the y-axis. That's all I really need to know at this point. I could find out some of the turning points, but to sketch it, we don't really need to know that. So let's draw a grid. Now, we've got what type of curve it is. It's a cubic, as I say. Where does it cut the x-axis? So it cuts the x-axis where y equals 0, all the way along this line here, y equals 0. So in other words, 0 equals x squared into x minus 3. So in this case, if 0 equals x squared multiplied by x minus 3, one of these factors is 0, because 0 only occurs when, in a multiplication, when one of the or both of the numbers you're multiplying by is 0. So in this case, x squared equals 0, which would imply that x would equal 0. And notice here there's a repeated root because of this x squared. We'll talk about that in a second. And also x minus 3 equals 0, which implies x equals 3. So this is going to cut, or it's going to cut the x-axis at 3. Let's cut the x-axis at 3 here. We'll make that 3. And at 0, it's going to touch the x-axis at 0. And it's going to do this because of this repeated root. So we know that this curve looks like this. Where does it cut the y-axis? Well, we can put that into this equation here. Let's see where it does that. So that would imply that y equals 0. So we put in x equals 0. So along this line here, remember, x equals 0. 0 into 0 minus 3, whatever that is. And y will equal, that implies y equals 0. So it crosses the y-axis at 0, which is what is implied by this root here. So this will look like something like this. Touches the x-axis at 0 because of the repeated root, and then it cuts the x-axis at 3. And that's that first part of the question. The second part of this question I've broken down into two halves here. We've got this polynomial that's given by this, so we've got x squared, x minus 3 plus 20 equals px, and we need to find the remainder when this function is divided by x minus 4. So from the remainder theorem, we know that if we substitute in x as 4 plus 4, so p of 4, we will get the remainder. So that will be 4 squared into 4 minus 3 plus 20. Which equals 16. 4 minus 3 is 1, so multiplied by 1, plus 20. So my remainder here is 36. So that's the first part. The second part to this, use the factor theorem to show that x plus 2 is a factor of p of x. So the factor theorem would suggest that if we put in p of minus 2, so we substitute in minus 2 in here. Remember, it's the negative of this. We would get minus 2 squared. I'm going to put this in brackets because it's a negative. And the temptation here is to say this is minus 4 squared. It's not. It's minus 2 times minus 2, which is a positive 4. So when I put it in brackets, negative numbers, I'm reminded of that fact. So then let's also put here minus 2 minus 3 and then plus 20. So as I say, we've got 4 here. Minus 2 minus 3 is minus 5. So let's multiply this by minus 5. And then I've got plus 20. So that would be minus 20 plus 20, which equals 0. So that's what we need to do to show that the x plus 2 is a factor of p of x. For the final part of this, we've got to express it in this form here. We've shown that this is a factor, and now we need to express it in this form here. So if you remember, p of x is x squared into x minus 3 plus 20, and we know that that will equal x plus 2 into x squared plus bx plus c, because it's suggesting that this is px. We need to express px in this form, so this is px, and we're given p of x before originally in the question. So if I multiply this out, first of all, this side here, I get x squared, so x cubed, because it's x squared times x, minus 3x squared plus 20 equals this. And we can see from this as well that if I divide by x plus 2, I will have this, divide both sides by x plus 2. So I could say x cubed minus 3x squared plus 20. And I could divide that then. I could divide that by x plus 2. So let's do that because it will equal this. We can then compare our coefficients and see what we get. And hopefully we will get value of b and c. Let's see. X into x cubed is x squared. X squared times x is x squared. X squared times 2 is x squared times x, apologies, is x cubed. There we go. X squared times 2 is plus 2x squared. Take that away. Minus 3x squared minus 2x squared will be minus 5x squared. Just remember, a neat trick here, if you get confused with this, just take it aside. Sometimes we have so much going on within the question that it's quite useful to take bits of it aside. Some people call that cognitive load, but I'm just saying if we're really overwhelmed by this, let's just take this out. So we want to do minus 3x squared minus 2x squared, which would be minus 5x squared. X into minus 5x squared is minus 5x. X times minus 5x squared is minus 5x squared. Minus 5x times plus 2 is minus 10x. We're presented with a problem here. We don't have an x term. So what I'm going to do is to take away from. So what I'm going to do is I'm going to erase that. I'm going to give us an x term here. Let's say it's 0 here. And we will put the plus 20 over here. So it would be 0 minus 10x. 0, which is here, minus 10x, which will equal positive 10x. Again, it's very easy to get caught up with these negatives and make mistakes with them. So it's important that you do what you have to do. There's no problem taking this out over here. Right, so we said that the answer here, 0 minus 10x, is positive 10x. X into 10x is plus 10. X times 10 is 10x. 2 times 10 is plus 20. And I know that I've got the right solution here because I'm left with 20 minus 20, which is 0. So expressing it in this form here, p of x in that form there would be x plus 2 multiplied by x squared minus 5x plus 10. So b will equal minus 5 and c will equal 10. And the last part to this, if we need to show that this equation here, p of x, this function, has exactly one real root and state its value. So if it has only one real root, then that means that this part of it cannot be factorized. So in other words, our cubic will only have one real root, so it'll only cross the x-axis once, and it could be like this. If it only crosses the x-axis once, the rest of it will be under or over the x-axis. It will only have one root, only cross the x-axis once. That's what that means. So if this function here cannot be factorized, we need to know about discriminants. The discriminant, remember, is the part of the quadratic formula. You can look at it like that, and it helps us out with this kind of thing. B squared minus 4ac. Very, very useful. If this is negative, then this cannot be factorized. It doesn't have roots. So b squared, b is minus 5, so minus 5 squared minus 4 times a, which is 1, times c, which is 10. And that equals 25 minus 40, which is minus 15. And because it's negative, in other words, we cannot find a real solution to the square root of minus 15. We know that this cannot be factorized, does not have any real roots. So that means that the real root, the real root is here where x cuts the x-axis. In fact, I've drawn this incorrectly. In fact, this will be over here, a minus 2, because it will be x plus 2. To find the root, x plus 2 equals 0. So x equals minus 2. So the real root is minus 2.